today is part 2 of practical tips and tricks with Spring integration. My name is Oleg Zhurakousky, and I'm one of the developers of Spring Integration Framework. I'm also developer of Spring MPP and the lead developer for Spring Integration Scala DSL projects. So for those of you who are interested in Scala, you can start following that one as well. But today is a continuation of the previous webinar, which is practical tips and tricks with Spring integration. Quickly, this webinar is not for the device users. So I would suggest if you're new to Spring integration, there's a great webinar on messaging and Spring integration from Mark Fisher, and you can find it on a YouTube channel. So this webinar also won't have many slides, actually only 2, the one you're looking at right now, and then the one with relevant links, which I'll display later. Most of what's going to be during this webinar is code. So let's begin. In this section, we'll talk about some of the more advanced features of a message channel. But before we begin, I want to say a few things. One of the things that differentiates Spring integration from its competitors is our commitment to treat enterprise integration patterns as specifications. And some of you may have heard me referring to Spring integration as a reference implementation of enterprise integration patterns. So there are a couple of reasons why we do this. Purity is one of them. We love getting a feedback from our community that after reading AAP book, they say that Spring integration is one of the simplest frameworks to learn, since developers can look at the pattern and find reference to it in Spring integration, thus making the process of transitioning from conceptual understanding of a pattern to its implementation quite an easy process. However, purity in itself is not enough of an argument. There are other more important values to understanding each and every pattern and how it can help you to accomplish some of the not so trivial use cases. So most of you have worked with other enterprise integration frameworks, I assume, and have already noticed our commitment to recognizing and promoting message channel pattern as first-class citizen, while other frameworks and products tend to look at it as sort of an internal detail. Why do we believe that channel is so important? Well, let's look at the following use case, and in fact, the first example actually talks about this. So in the last webinar, we've covered several ways of addressing error handling. We mainly concentrated on application errors and how you can implement error handling for such scenarios. But sometimes errors could be infrastructural, where a particular part of the system or a particular part of the message flow that you have might be unavailable. I mean, maybe your messaging system, maybe your JMS system crash, or maybe your web server is not available, or something along those lines. To better understand this, let's first look at this example in sort of a human terms. Let's say I need to convey a message to my colleague, and since I want to do it as soon as possible, I choose to call him or her over the phone. But suddenly I realize that due to the weak network signal or other phone problems, the call is not going through. Well, although it kind of created inconvenience for me, it's not really the end of the world, since I know that I can reach the person via different means, for example, over Skype or maybe email or some other facilities, which means I can get in touch with the person using sort of a different protocol. So essentially, we are talking about the use case where you may have a preferred protocol for message exchange, but in case a such protocol fails, you want to identify a secondary protocol. So in our example, I'll show you a simple system where producer and consumer exchange information via AMQP using RabbitMQ. However, if AMQP fails, we want our system to automatically and transparently to switch to a different protocol. And in our example, the secondary protocol will be JMS. So how can we accomplish this, and what relevance it has to message channel pattern? Well, message channel works in conjunction with another very important enterprise integration pattern called message dispatcher. which is responsible to dispatch messages to channel subscribers. So while message channel has a very simple responsibility, which is to establish a link between producer and consumer, message dispatcher has to know a couple of things. First, they have to know how to dispatch messages, which could be synchronous or synchronous. It also has to know how to handle multiple subscribers, since it has to adhere to the contract of the underlying message channel. For example, you may have multiple subscribers registered to point-to-point channel, where the contract is to dispatch message to a single subscriber always, versus a pop-sub channel, where as many subscribers as you have, that many subscribers will receive that message. So let's look at our sample first. In fact, I'm going to do it slightly differently. I'm going to run it and then introduce a condition, and we're going to see what's going to happen, and then we're going to look why it happened that way. So in our example, which you see right now on the screen, once we obtain the application context and get the gateway from the application context, we're simply going to send messages to the gateway with intervals of 1 second per message. And our configuration, in our configuration, we have a gateway, we have a channel, and it has a dispatcher configuration, which we'll discuss in a minute. And the important part here is that we have two outbound gateways configured as the subscribers to this input channel. So we have AMPP outbound gateway, whose request channel is input channel, right? And we also have a JMS outbound gateway, which is subscribing to the same channel. So right now, I'm going to run this example, and we're going to look at the console, and we're going to see what happens. So currently, I have RabbitMQ system running. So what I expect is that all messages will go through a single subscriber. In this case, it will be AMPP outbound gateway. So let's run it. So as you can see from the console, the messages are coming through, and you can see that based on the message headers, AMPP message headers, that every message is going through RabbitMQ, through AMPP protocol, right? So right now, what I'm going to do is I'm going to introduce this failure. I'm basically going to kill the rabbit. I'm going to kill RabbitMQ, and we're going to see what's going to happen with our message flow. So currently, as you can see, for us, everything is completely transparent. Our messaging system continues to run. So as you can see that right now the message flow continues to run, and the messages are right now going through JMS. And what I'm going to do right now, I'm going to restart the Rabbit. And Rabbit started, and look what happened. We're back to communicating over RabbitMQ. So now we can kill our process, and let's look what actually happened. So we're going to go back to our configuration, and let's look what's going on here. So first, we have basically the gateway, and the gateway is sending messages to the input channel. So the input channel is basically an input channel to both AMPP gateway and the JMS gateway. However, we see this very interesting attribute here called order. So the order, first of all, we have two subscribers to a direct channel, so the dispatch will only happen to a single subscriber. And the order defines which one is sort of primary, which one is secondary. So in this case, the lowest order defines the primary subscriber. So in our case, the AMQP gateway became a primary subscriber. Another interesting thing here is that, as you can see, in this particular channel configuration, we have another sub-element called dispatcher, which is an element that allows us to influence the configuration of this channel's message dispatcher. So this channel's message dispatcher comes with two capabilities. One is the failover, and another one is the load balancing. So in this case, we're going to cover load balancing in a few minutes, but in this case, I decided I'm going to configure it with load balancing none, load balancer none, which means it's not going to attempt to load balance our request. So in this case, what happened is every request that comes to this channel was distributed to the primary subscriber. However, when the primary subscriber wasn't available, basically when the primary subscriber generated the error, because subscriber is available, but the underlying system that it interacts with is not available. The automatic behavior of a direct channel is to fail over. And what failover means in this case, it's going to look for a second or third subscriber and so on and so forth. So any available subscriber that currently exists within the configuration is going to receive the message. And if that subscriber happens to process this message successfully, it essentially became that secondary subscriber. So that's how the system failed over to AMQP. But the order attribute is still honored by the message dispatcher, which means when I brought the rabbit and queue back up and rabbit and queue system became, AMQP system became available, the system went back to using the primary communication channel. In this case, it went back to using AMQP. So I hope you guys understood this feature, and if you have any questions, please start typing them in, and I'll try to respond to them at the end of this presentation. Now let's talk about another variation of this particular use case. So another variation of this use case is load balancing, which I already touched upon. So where a message dispatcher could be configured to load balance requests between multiple subscribers, which could be very useful when trying to implement sort of a MapReduce style scalable messaging systems, where messaging sort of load balances your request between multiple subscribers. And think about it this way: if you maybe on a single JVM, it doesn't make much sense, but if the subscribers are themselves delegates to remote systems, like in this particular case, you can actually distribute your load between multiple machines, if you wish. So let's look at that example. So what I'm going to do is I can either remove load balancer configuration, or I can switch to round robin. Basically, round robin is default mechanism, and before it was none, but round robin is default mechanism, so I can either leave it explicitly or I can remove it completely. For now, I'll just leave it explicitly, and I'm going to rerun our sample, and we're going to see how different the behavior is. So before, let's look at the log before. You can see that every message that was going into the system was going through AMQP. And until AMQP became unavailable, only then it switched to JMS. But while AMQP was available, it was always using AMQP. However, in this case, since I configured the load balancer to be round robin, I actually expect my system to equally load balance requests between two systems. So let's run it. And if you follow the headers, you can see that one request goes to Rabbit, another one goes to JMS, one goes to Rabbit, one goes to JMS, and so on and so forth. However, back to failover, I can still kill Rabbit, and all of a sudden you can see that every request goes through JMS. And if I try to restart the Rabbit, you can see that load balancing behavior will resume, and indeed it did. So as you can see, so I hope you kind of see the importance of the message channel, and especially the message dispatcher configuration of the message channel. Okay, so that concludes this first sample. Again, I already see you guys asking questions. I'll address them at the end of the presentation. But right now, we're going to move on to the next example. And the next example is all about asynchronous messaging, and specifically about the asynchronous gateway. So since we're talking about channels and message dispatcher and its responsibilities to know how to distribute messages, let's talk about the asynchronous communication and some of the advanced details of asynchronous communication. So messaging systems are naturally asynchronous, and even though we can build synchronous flows, it is not always the most scalable approach for several reasons. First, with a synchronous approach, your call to the messaging gateway will block until the reply is available. And in my opinion, there's actually a couple of problems with this approach. First one is you may want to do some additional processing while waiting for the response. And in a blocking style of programming, you won't be able to accomplish that. The second one is the reply, which actually happens quite often in today's world. The replies may only be relevant or valid if it is received within a certain time frame. If it's received after the particular time, it might no longer be valid or relevant or interesting. So how can we accomplish that? So let's look at a different example. So here's the asynchronous gateway example, and I'm going to first open a gateway. And as you already know, gateway is always a simple interface, but in this particular gateway, this interface has a very interesting feature because, as you can see, this interface returns, instead of some plain old Java object, it actually returns the future from Java Util Concurrent API. So, and when you define a gateway that returns the future, the Spring integration has a very interesting behavior. It basically executes the request asynchronously and thus returning you the future right away, and then giving you ability to interrogate this future later on when you expect the reply to come in, or So let's look at our code. So here's, it looks like there's a lot of code, but actually everything is very simple. So again, we're extracting the gateway from application context. And what I'm doing next is I'm invoking the gateway process method in a loop. And as you can see, the loop runs 100 iterations, and I'm adding all the results to the list of futures. Once I executed all the requests, I start another loop where I begin processing of the replies. Now, the interesting thing is that when I say result.get, basically extracting the future and executing a get method on the future, I execute it with a timeout, which is really talks about that use case that I just mentioned earlier, where a particular reply is only valid for a certain period of time. So in our case, we have a timeout set for 2 seconds, and which basically means that I'm willing to wait for the reply after 2 seconds, and if no reply will come in, then I'm no longer interested. So at that point of time, one of these exceptions down below will happen, basically telling me that, either timeout occurred or some exception happened. So let's run this code and analyze the output. All right, so let's go back up. So right now you can see that the result was processed. So we are receiving the actual replies. Hello from SpringOne. By the way, all these demos, all these samples from last year's SpringOne presentation. So that's why the logs say that hello SpringOne. However, what you see down below is saying the timeout occurred while waiting for the execution of the gateway method. And that message actually comes from here, right? Basically, I waited for 2 seconds and the reply didn't come. So in this particular case, I might just want to ignore the output or ignore the result. So I'm no longer interested. But the important part is that there was basically not a whole lot of blocking going on here because I process my requests with a gateway, and then at my own leisure, I start processing the results. And the results that, and while I was sending the request, I was also able to perform additional functionality. In this case, basically adding those results to the list, and and later on start processing them, at my own time, and sort of illustrating how I can submit all the requests synchronously, and then deal with the results later. So once again, I hope you understood the sample. And again, if you have any questions, please start tapping them in, and I'll respond to them as quickly as I can. All right, but right now we're going to move to the next sample. And in next sample, we're going to talk about some of the advanced as well as the new features of message aggregator. So typical aggregation use case that was supported by Spring Integration from its inception is to release a group of messages when such message group is complete. This means that there were a predefined number of messages that the aggregator would wait for, and that before release, and that number was specified via sequence size message header. However, another use case that was brought up to us several times through Spring Integration forums is to allow aggregator to aggregate messages that have no predefined sequence size. For example, batching, a very kind of a common use case where the messages come sort of as a stream, and there is no definitive end to a particular message stream, and I just want to be able to aggregate them in groups of 5 and release them in groups of 5. So that's very at the very core of this use case. However, if you kind of look at the aggregator pattern, there's a couple of interesting things to point out. So there's actually kind of sort of a conflicting use cases. One use case, you may want to say, you know what, I want to expect, I'm receiving a stream of messages, and once I receive a certain, group of messages, I'm no longer interested in the rest of the messages that belong to, let's say, this stream, that belong to this particular correlation ID. So we call that a late arrival use case. So in other words, once I release the group, let's say, of 5 messages, I'm no longer interested in any other message that comes after. So in other words, I want to be able to discard them. Another use case is, what if I do release messages in groups of 5, and I am interested in every group that is there. But let's say I have, which is in my particular example, let's say I want to release messages in groups of 5, but the number of messages that come in is not divisible by 5. In other words, let's say I'm sending 13 messages. I'm going to release the first 5, then the second 5, and then what should I do with the other 3 messages? I mean, are they going to remain in aggregator indefinitely? Or is there another way to be able to trigger the release of those messages based on, let's say, a time constraint or something like that? So let's look at both of these use cases in this example. So here's our example, and let's look at the code first. So again, very simple code here. So what I'm doing is I'm iterating in a loop and sending basically 13 messages in intervals of 1 second to a input channel that's defined within my messaging flow. And let's look at the configuration. Configuration is very simple. So in this configuration, we have an aggregator, and which is configured with both discard channel and the new attribute that came with Spring Integration 2.1 called expire groups upon completion. And as you can see that the aggregator will output groups of messages to the logging channel, and if there's any messages that needs to be discarded, they will go to the discard channel. And let's not worry about the rest of the configuration. We'll look at it in a second. So let's run this example. as you can see, messages are coming in, and now they're being aggregated. So it was released for the first time. There's a second release of messages. Now we have 3 more messages come in, and there's a pause because, there's no more messages coming, but all of a sudden we see a third release, but the third release only has 3 messages. So let's see what happened here. For that, we're going to go back to configuration and look at some of the details. So what happened is the following. The messages were aggregated in groups of 5, and actually I didn't show you this. Oops, sorry. The reason why they were aggregated in groups of 5 is because of the release strategy expression. It says basically as soon as the size reaches 5, release them. So that's my release strategy. And the messages were released to the logging channel. However, at the very last iteration when I sent 3 messages were just sitting there, and obviously they did not satisfy the criteria of this release strategy. So something else had to trigger its release. So, and for that, what we did here is we configured a message group store reaper, which is a component within Spring integration. And the reaper sets the timeout, says, listen, each group within a particular message store, you can see that we're both referring to the same message store. So the message group reaper will be ran by task executor, but basically by scheduler. In this case, the reaper runs every 100 milliseconds. Right? So the task scheduler runs the reaper every 100 milliseconds. And the reaper, what it does, it iterates through a message group store, and it evaluates every single message group. And every time the message is put into the message group, the timestamp of the message group is updated. So the reaper always has all the information that it needs. It basically says, listen, when was the last update on this message group? And if that update is already over 5 seconds long, then I'm going to release that particular group. So that's what the timeout stands for. So in this case, the reaper has been run, and that's why there was a pause, because we needed to wait a little bit. And as soon as a particular group where we were adding messages went past 5 seconds, its execution time went past 5 seconds, the reaper actually forced the release of this message group. So that's why it worked. Now, another interesting thing here is this attribute called expire groups upon completion equals true. What does this mean? In previous versions of Spring integration, we did not have this attribute, and that's why we were always relying on the predefined size of the message group. Well, in this case, it's not a predefined size because we don't know how many messages will come in. In fact, our messages are missing the sequence size header because we don't know what the sequence size is. So, in this particular case, we want to be able to, after release, we have 2 scenarios. We want to be able to accommodate 2 use cases. One is the late arrival, which we'll talk about in a second. Another one is what you just saw, which is the ability to treat every message group as a brand new message group. So what happened is that every time the release of groups of 5 happened, that particular message group had expired. Actually, that particular message group was marked as complete, and therefore any reference to this message group was removed from the message store. So when the new message came in with the same correlation ID, it started a new group, it started a new accumulation of messages, and hence the behavior that we just saw. However, as I was describing earlier, there might be a situation where you may want to say, listen, I want to get this first 5 messages, and once I get them, I'm no longer interested in the rest of the messages. So for that particular use case, you want to be able to somehow tell the aggregator that you want to discard the rest of the messages. And that's why we had to introduce this attribute, so you'll be able to manipulate between these 2 different use cases, between these 2 different requirements. So what I'm going to do right now is I'm going to set this attribute to false and rerun the same demo. And we'll see how different the behavior is going to be. So let's quickly review what happened before. Before we were sending, 5 messages, then we see aggregation happened right here, then 5 more messages, then aggregation, then 3 more messages, then a little pause, and then finally the aggregation that was accomplished by the reaper. Okay? Now, in this case, things will happen slightly different. So let's run them. You can see the same thing happening. And now aggregation, and look what happens now. So right now, every message that comes after is being discarded, because what happened is, since I set expire message group upon completion to false, although the messages were removed from the message group, the reference to the particular group remains within the message store. And because it remains within the message store, the aggregator knows that this particular group was completed, and therefore every message that comes after needs to be discarded. And it sends it to a discard channel, and our discard channel is pointing to another instance of a logging channel adapter, where we're logging it, and hence you see this output: discarded, discarded, discarded. So I hope you understood. Again, ask questions. I'll try to answer them later. But time to move on to the next use case. So, and in the next use case, we're going to be talking about the actually very interesting requirement. So we have this unbounded resequencer. So it's going to be about resequencing. Let me find it. There we go. The configuration is actually very simple, but let me describe what the use case is all about. So in this particular use case, we have messages that come in with unordered, right? And we want to be able to order those messages and release them in order specified by the sequence. So the interesting thing here is that what we also want to do, and this is what makes this use case interesting, we want to be able to process messages that belong to the same group in sequence serially. But the messages that belong to a different message group, we want to be able to process them concurrently with the other message group. In other words, if I have a message group that's with the correlation ID 1 and a message group with the correlation ID 2, these two groups between themselves can process concurrently. But all the messages within group 1 should process serially. So how can we accomplish that? Well, so in this case, I have my resequencer that sends messages to the output channel, which is distribution channel, which is just a direct channel here. And the distribution channel is pointing to the service activator, which we are about to look at. So in this service activator, that's where we're going to be doing our processing. And this service activator helps us to accomplish this particular use case. So let's look at it. So first, we see that I'm sending messages with in different order. So we have two different correlation ID. We have correlation ID 1, correlation ID 2, 1, 2, and so on and so forth. And we're setting a sequence number. Again, as you can see, every message comes in a sort of unordered fashion. And what resequencer is supposed to do is supposed to release them sequentially, right? But as soon as it releases them sequentially, they're going to be hitting this service activator. And when it hits the service activator, let me just reset the sample, the service activator will process them as they come in. But the interesting thing, if we just simply leave the service activator the way it is right now, as you can see, the service activator will process them sequentially. And what happens is, once I run the sample, you can see that the messages for different correlation IDs are still processed sequentially. In other words, correlation ID 1 and correlation ID 2, you know, if message for correlation ID 2 comes into the service activator, it's waiting for the message for correlation ID 1 to process. So in other words, it's not very efficient. So what we want to do, we want to be able to make sure that messages that belong to different correlation IDs are processed concurrently. So, and for that, we're going to uncomment this code and talk about it real quickly. So what I'm doing here, I'm just using a semaphore. And for each correlation ID, I'm basically storing the semaphore in a concurrent hash map. And what happens is that I'm executing within this process method, I'm executing my process concurrently. But while executing it concurrently, I'm basically doing the locking based on the correlation ID, which means that if two messages came in and those two belong to the same correlation ID, they will be processed sequentially, even though the process looks like it's going to process serially, because the message with the same correlation ID will wait for the lock to become available. However, if messages belong to a different correlation ID, obviously to a different lock, now they'll be able to process concurrently. And if I rerun this process right now, you can see that it's going to be much faster and more efficient, obviously. So the output is the same, but you can see that the process is much faster and obviously more efficient. So that is basically something that you can do when it comes to addressing this use case. And this question actually comes up quite often, so I referred to the samples, referred a couple of users to the samples already before. All right, so I think we're done with this sample. Again, please type in your questions. And looking at the time, I think we have time for one more demo. And in this particular demo, what I'm going to show you is actually one of the new features of Spring Integration 2.1, and it has to do with the content enrichment pattern. So I'm sure you're all familiar with header enricher. It's been part of Spring Integration from the very beginning, and header enricher obviously enriches message headers. But what if you have a use case where you want to utilize special type of transformation where you want to be able to enrich a payload of the message? But the interesting thing is you can say, well, yeah, I can use a transformer and, you know, enrich the payload of the message. But what if you want that enrichment process itself to be another message flow? And that's what the enricher, the new component of Spring Integration 2.1 does. So let's look at the configuration. And in this configuration, we have a new component called enricher. And the interesting thing about this component is the fact that you actually see not two, but three channels. There's a special transformer that allows you to, you know, enrich the payload of the message. But why does it have three channels? Well, that's actually quite interesting. So the input channel is a typical input channel, which will be responsible to send them to, you know, get the message to this particular endpoint. And the output channel is where this endpoint will send the message once it's done processing of the message. However, we also have this channel called request channel, which points to basically another channel. And in this case, it points to enrichment channel, which is the request channel of this particular HTTP outbound gateway, right? And we'll talk about it in a second. And basically, there's another message flow. So from gateway, go to transformer, then to JSON to object transformer, and this logging channel adapter, and so on. So the whole point here is that once the message comes into the this enricher, before enricher does anything, it's going to send this message as is to this enrichment channel. So in other words, now we're trying to delegate this message to another messaging flow where we'll be able to receive a reply from. And once we receive the reply from this, we'll be able to enrich our original message with the information that came from the message that was received as a reply from this enrichment channel. And when we sort of aggregate or merge all the responses based on, you know, based on the information, based on the configuration provided here, where, for example, we are, these are all properties of the payload object, we'll release this message to the output channel. So let's look at our sample. So we have this object, which is going to be our payload. In this case, it's a company. And we have these properties: name, ticker, updated, market information, update place, and everything else. However, as you can see, when we're creating company, we're only setting two attributes: name and the ticker symbol, right? And we're sending it out. So in other words, a lot of the attributes of this particular object are missing. However, when we receive the reply, we should be able to see an enriched company object, which should contain, in fact, in this case, a real-time market information, since we're using a real-time Google Finance API to actually get information on a ticker symbol that we supply here, in this case, VMware. So let's run this sample. So you can see that we're sending company VMware, and our toString method says that VMware only has, the name of the company and a ticker symbol. However, once we receive the reply, which is the logging handler, now we actually have a fully initialized company object, which has the name and the ticker symbol the same. However, it also has the information that was provided that we received in real time from the call to this HTTP outbound gateway, slightly transformed to accommodate our scenario. So this is actually again a good way of creating a transformation, writing a transformer where the transformation logic itself must be encapsulated into a separate message flow. So there's, of course, another way of doing it where you can, for example, inside of your Pojo transformer, make a second message call invocation through a gateway or something along those lines. But this approach actually allows you a very nice and configurable way to define your enrichment logic while receiving your enrichment data from another message flow. All right, so at this point of time, I'm going to conclude this demo, and I'm going to start looking at the questions, and hopefully there are interesting questions. All right, so I have quite a few questions. So the first question is, can you configure your channel to be environment-centric? For example, dev gateway versus load gateway. Yes, it's actually a very interesting question because you know how we always say that Spring integration and every other Spring project, we're not just using Spring ourselves, we actually build on top of Spring. So so in this case, for those of you who are familiar with Spring 3.0 and the profile feature, that's how you would accomplish this use case. Unfortunately, I won't have enough time right now to change my presentation to show that. But if you look at Spring profiles, you basically will be able to create several channels. Actually, let me show you something from a different demo, but it will kind of show you the. Come on. All right. So let's look at one of the configuration that has the profiles. It's from a different demo. Okay. So it's not pointing to channel, it's pointing to different types of objects, but it would be the same thing. So for example, in this case, it's a Cloud Foundry demo where I have, for example, two different connection factories. One that I'm supposed to use when I'm running it locally on Tomcat, for example, while another one I'll use when I'm running in the Cloud Foundry. And I want to be able to deploy the same jar, the same WAR file, the same way as I want to deploy it the same way to Cloud Foundry as I do to the Tomcat. And so in other words, I want that switch between the environment happen transparently for me. And this is the feature of the profiles, saying when profile is local, use this connection factory. When profile is cloud, use this connection factory. You can see that they're pointing to the same name, but the instance is going to be differently based on the environment. So you can see that this new profiles feature allows you to create beans, sub-element within beans, and identify the profile. And so you'll be able to provide any type of configuration here, and the configuration which is encapsulated within the beans profile will be specific to that profile. So to answer your question, you'll be able to configure channels specific to your environment by utilizing Spring profile features. So I hope that answers. Now, the next question is, is Spring integration JMS thread safe? Well, again, that question is not specific to Spring integration. That question is basically using the underlying JMS system. And again, to answer this question, you kind of have to give me a little more details. What do you mean by thread safe in this particular case? So I'm going to skip that for now. Maybe you can type up the follow-up or something. Is it possible to plug in an alternate load balancing algorithm? I see none and round robin available. Could you add custom behavior? Yes, you can do that. In this case, you would have to configure channel as a bean and provide the message dispatcher, and you'll be able to inject so load balancing is actually a strategy with Spring integration, and you'll be able to implement whatever different load balancing strategy you have. And we're actually thinking about providing a configurable option for that, but for right now, if you just want to use the namespace support, it's, as you said, it's round robin or none. But if you want to provide your own custom load balancing strategy, then you'll be able to do it by simply creating a channel as a bean, which is actually very simple to do. How do we stop processing messages from gateway depending on some condition? I'm not sure I understand. Well, if you there's an enterprise integration pattern called filter, and if you were actually designed for that purpose, where you receive when the filter receives the message, you define a condition which the filter always returns either true or false. That's the responsibility of the filter. So the filter will only allow the message to proceed if the condition that you specified returns true. So I hope that's what you're asking. So in other words, if you want to process something conditionally, all you need to do is define a filter. And in fact, the filter was, some of these use cases about filtering the message flow were discussed in the previous webinar. Actually, you can go and look at it at the YouTube channel. As the moderator mentioned, it was recorded and it's available on the Spring Source YouTube channel. Next question. Does Spring integration support clustering? Well, again, it's a very vague question. Clustering in today's world can mean many different things. And in fact, what I did today when I was distributing the load between JMS and AMTP could in itself be considered as clustering. So, but I think what you're asking is about conventional clustering, like, server clustering and so on and so forth. Obviously, the server clustering is vendor specific, and Spring integration is framework. So in that sense, it's not supporting the conventional clustering because it's a framework. But again, the clustering, you probably want to ask a more detailed question specific to a particular use case, because this question is being asked on forums quite often, and we typically ask people to provide more details, what exactly you're trying to accomplish. And more often than not, we are able to find a more concrete solution with Spring integration, where you can accomplish the scenario where you have multiple instances of the same system running, and you want to represent them as a single image. So then again, you got to give me a more specific use case scenario. How can we load balance a request based on a specific response from the outbound gateway? The use case being that the transport may provide a response and hence the connection is valid, but the response has a token that indicates the backend server is down. Well, that's, again, a very good question, a very interesting question, and that's, again, when you kind of go back to the enterprise integration pattern book, and you'll find a very interesting pattern called message router. And so essentially in this case, from the infrastructure standpoint, you did receive a successful response, but the response itself contains information that tells you that something is not right. And in this particular case, you can generate an error, and by generating this error, you essentially, the error will be caught by the dispatcher, and the dispatcher will fail over or load balance, to a different subscriber. So again, a very simple way to accomplish that. So again, let me just add something else. So in our case, the one I demonstrated today, I actually was talking more about the infrastructure failure where my adapter was fully initialized and configured, but somewhere in the middle of its life cycle, the underlying system that it's being connected to failed. So what you're talking about is that the adapter was healthy and the underlying system was healthy, but what was processing within that underlying system wasn't healthy. So you got a response which, from the infrastructure standpoint, constitutes a success, but the response itself is an error. And what you can do in this case is trigger an exception if you want Spring integration itself to do the failover for you. All you need to do is just trigger an exception in that case, and once the exception is going to be caught by the message dispatcher, and there's a second subscriber available, it will delegate the request to that subscriber. And next question. In short, can we define the load balance based on the response element? Well, you define load balance based on the request. I mean, I'm trying to understand what you're asking. So, you send the message, and the dispatcher dispatches the message to either this subscriber or that subscriber. So the message channel itself did not provide you with any response. So if you're talking about load balancing based on a particular data inside of the message, that actually goes along with the previous question that was asked about, can you configure a custom load balancing policy? And the answer is yes. But as I mentioned earlier, you would have to configure channel as a bean and provide your load balancing strategy there. In that case, you'd be able to look inside the message and load balance accordingly. So next question. Can the aggregator be configured to release a group when the size reaches 5 or 1 second has passed, whichever comes first? Yes, absolutely. So for example, I could configure my message groups to a Reaper to, in this case, if I were to send, when I send 3 messages, if I were to send 2 more messages after that, but would wait a little more, then the 3 messages would be released, and then the other 2 would come in and they would be released. So the answer is absolutely yes, and in this case, exactly as you stated, whichever comes first. So in other words, if there's a period of inactivity, that's specified by your timeout, the messages that are currently inside of that message group are going to be released. But if, let's say, after the release, 2 more messages came in, then that's what's going to happen. They're going to be like a brand new group, and they're going to be released later on when their timeout will expire. Okay, next question. Okay, if I use JMS-backed queue, do we have any way to configure the retry policy? Again, the retry use case was covered in the first webinar, so I would suggest to review it on YouTube. And again, the retry is part of this sample, so you can go to, so this is actually the link for YouTube, so that's the first webinar, the part 1, and all the samples are available on GitHub. Just find me on Oleg Z and S12JX 2011. So this is the retry sample. It's right here. You can see retry, so you can look through that sample and hopefully that will answer that question. All right. In the aggregator, can you configure the number of threads that the aggregator used to concurrently group items? I'm not sure I understand why you need to concurrently group items. Maybe you can clarify, because grouping is just a very simple process. I don't see the need for concurrency there. Because aggregator is basically a stateful component that simply stores messages. It doesn't do any other processing. So I'm not sure how concurrency, what role concurrency would play here. Maybe you can clarify with the different question. So the distribution is what happens, through the message dispatcher, and that's where you want to distribute concurrently or serially, and that's what the message dispatcher does for you. But the aggregator is just an endpoint that receives messages either concurrently or serially based on the message dispatcher that dispatches messages to a particular aggregator. In TC server, I can enable session clustering, therefore I don't need to resubmit transaction. Let's say if I have two Spring integration, well, hold up. Of course, the instance 1 goes down, I want the instance 2 to continue the transaction. Yeah, so I understand what you're asking. Unfortunately, I won't be able to, within 30 seconds to come up with the answer. What I would suggest is to ask this question on the forum, provide all the details, and we'll see what we can come up with. Okay? So it is a very interesting question. It's a valid question, but unfortunately, I don't want to dance around with very speculation. I'd like to think about it more and give you sort of a more realistic answer. So definitely ask this question on the Spring forums. Is it possible is it possible to have, I guess, two attack configurations? Yeah, of course it's possible. It's just, I think it's a follow-up to your other question. You want to be able to look at these two configurations sort of as a single image because you're utilizing, session clustering. I mean, personally, I would never use session clustering to begin with, but that's a whole different story. So, like I said, still post this question on the Spring forum. We'll see what we can come up with. Looking for more questions. Okay, you need to concurrently group in the context of a stream of execution in a financial securities context. Single threading execution group by their order will be way too slow. You must process concurrently. Okay, so that's a follow-up question to the aggregator in concurrency. So that's what I was saying before. The aggregator is a stateful component. It basically groups messages as they come in. So there's no, and it groups them based on the release, based on the correlation strategy, right? So, but the concurrency comes with the way how messages hit the dispatcher. So in other words, if the dispatcher's input channel is a direct and synchronous channel, then obviously the grouping itself will happen synchronously. But if the input channel to the aggregator is the asynchronous channel, for example, let me go back to the aggregator example and show you what I have in mind. But right now, since I understand what the question is all about, okay, so here's our aggregator, and in this case, aggregator defines an input channel. And this input channel is not explicitly defined because, as you already know, the input channel itself, the input channel, if it's not explicitly defined, will be auto-created as a default direct and synchronous channel. However, if I, for example, say, and again, I will use a dispatcher configuration, and I will say task executor, and let's say I'm going to have another task namespace, for example, task executor ID executor, and full size. Let's say we have a 10 threads available to us. So right now, when I send messages to this input channel, now I just configure this channel to be an asynchronous channel. So right now, all the messages are going to be dispatched to this aggregator asynchronously, hence the aggregation itself will happen asynchronously. So I hope that answers your question. All right. Okay, guys, so actually exactly 1 hour since the start, and I was able to answer all the questions. So I hope you enjoyed it. Actually, let me switch to this slide. Here you see all the relevant links. For example, the reference to enterprise integration patterns is available on this website, but I would also suggest to buy a book because this website provides a very high-level introduction to enterprise integration patterns, but you probably want to read more details. The Spring Integration homepage and Spring Integration forums, this is where I encourage all of you to ask more questions, especially if the questions are very advanced, where we have to probably work with you to come up with a solution. It's the best place to do so, and you can, do some searches and browsing, and you can see how that actually works, how a lot of our users, through a discussion, through a thread, were able to accomplish some of the advanced requirements. If you feel there's a problem or you would like a new feature, you can obviously use Spring Integration Jira and raise the issues there. As I mentioned earlier, I'm also the developer for Spring Integration Scala DSL. There's actually a Groovy DSL in progress as well. So basically, the alternative to XML style configuration is going to be available relatively soon, and we'll probably have separate webinars for that. And these demo samples that were part 1 and part 2 are available on GitHub. Just here's the link, but you can just go to GitHub and find Oleg Z. That's my handle, and that's the name of the sample. So unless there's any more questions, which I don't see any, I would like to conclude this webinar, and I'd like to thank you all for joining. I hope you enjoyed it, and if you guys still have any more questions about what you saw today, once again, please ask them on the forum, and me or my colleagues will be more than glad to respond and to help you out. So thank you very much. You have a great day, and hopefully to see you next time.